Question number 7. We need to prove that when you get sine A times sine of 60 minus A times sine of 60 plus A, that you will get a quarter sine of 3A. Let us look at the solution. So we shall first of all consider the left hand side, that is sine of A times sine of 60 minus A, then times sine of 60 plus A. So we need to prove that one, the left hand side, is equivalent to a quarter sine of 3A. So since that is our interest, before we look at how best we can place the identity of sine of 60 minus A into sine of 60 plus A, it is important that we recall some of these identities. That when you have sine of A minus B in times sine of A plus B, using the expansion of this compound angle, that is sine of A minus B times sine of A plus B, that this one will always give you sine squared A minus sine squared B. And for that case, if for us we have sine of 60 minus A times sine of 60 plus A, we can as well write this as sine of A times, where there is sine 60 minus A times sine 60 plus A, I can put its equivalent identity as sine squared of 60 times that minus sine squared of B for our B, that is A for our case. So this one here will be an equivalent identity of sine of 60 minus A times sine of 60 plus A. So for that case, we shall have sine of A times sine 60 is same as root 3 divided by 2. So this one will be squared minus sine squared of A. And this will be same as sine of A times 3 divided by 4 minus sine squared of A. From there, we can pull out a quarter, and this will be same as a quarter, since that is our interest, sine of A into this one will be 3, this one will be minus 4 sine squared of A. From there, we can easily have this as a quarter into, this is sine of A minus, this is 3. 3 is here, we are multiplying sine A times 3, that is 3 sine of A minus 4 sine to power 3 of A. So clearly, we can easily realize that this is an identity of sine of 3A. So it is very true that the left hand side is giving us the right hand side as per the equation. So you realize that this side here, that is sine of A times sine of 60 minus A times sine of 60 plus A, is actually equivalent to a quarter sine of A. And this will be the answer for the question number 7. Question number 8 says, we show that the 4 points 1, 0, 2, negative 7, 8, 1, and 9, negative 6 are concyclic. So in order to show that these 4 points here are concyclic, it is sufficient to show that these 4 points here lie on what we call a common circle. So our interest will be to show that all these 4 points here will be lying on a common circle. And we know that from the general equation of a circle, which is x squared plus y squared plus 2gx plus 2fy plus c equaling to 0, we shall first of all use these 3 points, 1, 0, 2, negative 7, 8, 1, to get the equation of the circle, and then we see whether 9, negative 6 will be able to satisfy that same circle. That is the equation of that same circle. Now for that case, let us first of all get the equation of the circle that connects points 1, 0, 2, negative 7, 8, 1. So we shall begin with point number 1, which is point A, which is 1, 0. And from the general equation of the circle, we can have x and y. So our x for this case will be 1 and y will be 0. So we shall substitute. So for 1, 0, it implies we shall have 1 squared plus 0 squared plus 2g into 1 plus 2f to 0, then plus c equaling to 0. And basically this will give us 2g plus c, this will be 1, and when 1 crosses equal signs will be negative 1. So this will give us equation number 1. Similarly, let us look at another point, that is point 2, negative 7. So we are substituting within the equation of the circle, and from here we shall have 2 squared plus negative 7 squared plus 2g into 2 plus 2f into negative 7, then plus c equaling to 0. So this will give us 4g minus 14f, this one here, then plus c. This will be 4 plus 49, which is 53, then which will give us, when it crosses equal signs, negative 53. So this will be equation number 2. Similarly, point C, that is 8 and 1. 8 and 1. Doing the same, we shall have 8 squared plus 1 squared plus 2g into 8 plus 2f into 1 plus c equaling to 0. So this will give us 16g plus 2f plus c equaling 2. This will give us 64 plus 1, and this, when it crosses, negative 65. This is equation number 3. So having 3 equations, 1, 2, and 3, we solve them simultaneously to get the values of f, g, and c. Now, solving these equations here, we can begin with equation number 2 and 3. We eliminate f such that we can look at that expression with 2g plus c, and we can easily get the value of g and c, which we shall substitute to get the value of f. So next we are getting equation number 2. So we are saying from equation 2 and equation number 3. From equation 2 and equation number 3, we are having 4g minus 14f plus c equaling to negative 53. Then we are having 16g plus 2f plus c, which is equal to negative 65. So that is from equation 2, this one, and this one here. So from these two equations, we want to eliminate f. We want to eliminate f such that we can use it with equation number 1. So from here, if we want to eliminate f, we shall multiply this by 7. We add the two equations, and this one here will be able to give us 116G plus 8C, which is equal to negative 508, and this can be equation number 4. So from equation number 4 and equation number 1, this equation here and this equation, this one here, so we shall be able to have two unknowns only, that is G and C. So that is, we can get equation number 4. Let us get equation number 4. We subtract 8 times equation number 1. So we want to eliminate C first. So when you get equation 4, this equation, then you subtract equation number 1. You subtract equation number 1, 2G plus C, multiplied with multiplied with 8. Then we shall be able to remain with G as negative 5. So we shall be able to remain with G and negative 5, and C will be 9. So we shall be able to get G as negative 5 and C as negative 9. You can solve that one easily. You have 116G plus 8C equaling to negative 508. Then you also have equation number 1, which is 2G 10 plus C equaling to negative 1. So we are saying you multiply here by negative 8. So if you multiply by negative 8 here, then you subtract the 2, that is 118G minus 8 multiplied into the whole of this. Then you will be able to get your G as negative 5 and C as 9. So after getting G and C, we look at how best we can obtain F. So we shall consider from equation number 3, which is 16G plus 2F plus C equaling to negative 65. So we have 16 times 5, 16 times G, our G is negative 5, plus 2F plus 9 is equal to negative 65. So for this case, we shall be able to remain with F at 3. So we have F at 3, we have G as negative 5, we have C as 9. So from there, we can now say the general equation. The general equation will be x squared plus y squared plus 2g, that is 2 times negative 5 of x, plus 2f. F we have got it as 3 of y, then plus c, which is 9, equaling to 0. So we are substituting in this general equation, that is x squared plus y squared. G, we have got it as negative 5. We have got f as 3. We have c as 9. So from there, we are getting the general equation of the circle, which is passing through 1, 0, 2, negative 7, and 8, 1. So from there, we can clearly have this as x squared plus y squared minus 10x plus 6y plus 9 equaling to 0. So this is the equation of the circle which passes through the 3 points. But now, since we need to show that all the 4 points lie on the common circle, then we shall now need to test for the remaining points. Now we need to show that the other last point, that is 9, negative 6, lies on the circle. So it will lie on the circle if it satisfies this equation of the circle. So if we call this one equation star star, so it means from star star, which is this equation, it means we can have x squared plus y squared minus 10x plus 6y plus 9. This one will be same as, let us substitute this point here, 9 negative 6. So this will be 9 squared plus negative 6 squared minus 10 into 9 plus 6 into negative 6, then plus 9. So this will be same as 81 plus 36 minus 90 minus 36 plus 9. Clearly, we can see that negative 90 and 90 will give us negative 81, which will be added with 81 to give us 0. 36 minus 36 will give us 0. So this expression will be equal to 0. Now it is very clear that the point 9 negative 6, the point 9 negative 6 satisfies the equation of the circle. So since the point 9 negative 6 satisfies the equation of this circle, which is passing through the points, that is 1, 0, 2, negative 7, 8, 1, 9, and negative 6, then we shall conclude that these 4 points here are concyclic.